Hey there. So, you've probably found the slope of a line by counting rise over run on a graph, right? You count the little boxes up and then you count them over. It works until it doesn't. Well, in this explainer, we are going to totally level up that idea with a powerful formula that works every single time, no matter how wild the numbers get. Honestly, this little formula is one of the most important tools you'll learn in algebra. So let's just dive right in. All right, here's our game plan. First, we'll talk about why we even need to go beyond counting boxes. Then we'll break down the slope formula itself. After that, we'll put it into practice. I'll show you how to avoid some super common mistakes. And finally, we'll see where this thing actually shows up in the real world. Okay, let's get into it. We're going to start with what you already know, that whole rise over run thing, and see how we can give it a serious upgrade. Yeah, we've all been there, right? You draw that little triangle on the graph, you count the boxes. It's a great trick. But let's be real. What happens if your points are like 1, 2 and 100, 250? Are you going to draw a graph that big? No way. Or what if you have decimals like 3.7 and 8.1? All of a sudden, counting boxes is a total nightmare. And this right here is the huge leap we're making today. We're ditching the counting method, which is stuck on the graph paper, and moving to a calculation method that works for any 2 points anywhere. And here's the really cool part. When you're counting the spaces between 2 points, what you're really doing is just finding the difference. And in math, the best way to find a difference? Well, that's just subtraction. That is the key. So, with that idea in mind, let's check out the tool that makes it all happen. This is the slope formula. And trust me, it's about to become your new go-to. And there it is. Slope, which we call m for some reason, equals y2 minus y1 all over x2 minus x1. I know, it looks a little intimidating with all the subscripts and stuff, but I promise you it's just a more grown-up way of writing rise over run. Let's just tear this thing apart for a second. That top part, the numerator, that's just the change in the y values. The vertical change, the rise. And the bottom part, the denominator, is the change in the x values, the horizontal change, our run. See? It's literally the same thing, rise over run. Okay, now listen up, because this is the golden rule. If there is one thing you remember about this formula, let it be this. You have to be consistent. It honestly doesn't matter which point you call point 1 or point 2, as long as you start with the same point on top and on the bottom. If you mix them up, it's game over. All right, enough talk. Theory is great, but the only way to really get comfortable with a formula is to actually use it. So let's run through 3 quick examples, and we'll start easy and then add a little spice. Okay, first one. A nice, straightforward problem. We need to find the slope of the line that passes through the points 4, 1 and 6, 9. So here's how I like to do it. Step 1, just to keep things from getting messy, let's label our points. We'll just call 4, 1 our first point, so that's x1, y1. And 6, 9 will be our second. Now we just plug those numbers into the right spots in our formula. On top, we need y2 minus y1, that's 9 minus 1. On the bottom, x2 minus x1, that's 6 minus 4. And now, the easy part, we just solve it. 8 divided by 2 gives us 4. So the slope is 4. And what does that mean? It just means for every one step you take to the right, you go up 4 steps. See? Simple. Okay, let's level up. Now we're going to throw some negative numbers into the mix. This is where you really have to pay attention to the signs. So the most important thing here is to watch those signs. The numerator is pretty simple. -5 minus another 5 gets us to -10. But look at the bottom. We have 3 minus a -2. And what happens when you subtract a negative? Right, it becomes a positive. So it's not 3 minus 2, it's 3 plus 2. That's the trap. And that one little sign change makes all the difference. We get -10 divided by 5, which is -2. So this line has a negative slope, which just means it's heading downhill as you go from left to right. All right, one last example. Now this one looks super simple, but it's actually set up to show us something really important about a special kind of line. So let's see what happens when we plug these into the formula. On top, for our rise, we've got 4 minus 4, which is 0. On the bottom, for our run, we have 5 minus 1, which is 4. So we end up with 0 divided by 4. And that's totally fine. Think about it. If you have 0 cookies to share with 4 friends, everybody's getting 0 cookies. It's a real answer. A slope of 0. That's it. And what does a line with a 0 slope look like? Well, it's perfectly flat, a horizontal line. It has zero rise. It's not going up or down at all. Okay, before we go any further, let's just quickly talk about the two biggest mistakes that people make with this formula. If you can keep these two things in mind, you are going to save yourself so much trouble later on. Mistake number one, without a doubt, is getting the x's and y's mixed up. It is so easy to accidentally put the x's on top. So just burn this into your brain. Rise over run. The rise is vertical, that's your y-axis, so the y's always go on top. And the other big one is that minus a negative trap we just saw. It's so easy for your brain to just see the two numbers and subtract. So here's a pro tip. Whenever you plug a negative number into the formula, always put it in parentheses. It's like a little visual alarm bell that screams, "Hey, look out, you've got a double negative here," and it'll remind you to change it to addition. So, after all that, you might be wondering, okay, cool, but when am I ever actually going to use this? Well, let's connect this to something you definitely understand, a road trip. Check this out. Let's say time is our x value and distance is our y value. So our first point is 1 p.m., mile marker 10, and our second point is 3 p.m., mile marker 130. When we plug that into the slope formula, what are we calculating? We're finding the change in miles on top and the change in hours on the bottom. The answer we get, 60, is miles per hour. That's your average speed. How cool is that? Slope is just a fancy word for rate of change. And that leaves us with a really interesting question. This formula is perfect for straight lines because the rate of change is always the same. But what about a curve? Think about a rocket taking off. Its speed is changing every single second. How could you possibly measure its rate of change at one single instant? Well, that exact question is what led to the invention of calculus. So by mastering slope today, you're not just learning algebra, you're building the foundation for some of the biggest ideas in all of math.